Relative velocity. Imagine you're in a car and you are travelling along the M1 and you're doing 100 kilometres an hour, and you have a car next to you in the other lane that is also travelling at 100 kilometres per hour. So here's A, here's B. So the velocity of B relative to you, you look across and you look at the other, and you're both travelling, you're both side by side, travelling at the same speed. So the velocity of B relative to A would be zero. They're not moving. As far as you look across, they're not going faster than you, not going slower. So the velocity of B relative to A would be equal to zero. Let's look at another example. You're going, hopefully not in the same lane, but you've got another car that's coming back in this direction. So if you're doing 100 kilometres per hour and they're doing 100 kilometres back this way, this car over here, relative to you sitting in car A, is going to look like it's travelling at 200 kilometres per hour because you're going 100 this way, they're coming 100 that way. So the velocity of B relative to A would be 200 kilometres per hour. So that's all fine when A and B are travelling, if you like, along the same line. So what the problem arises, or not the problem, but most scenarios are when they're not both travelling on the same line. And for this we might look at, let's look at an aeroplane. Now that aeroplane will take off and it's going to travel in this direction. But lo and behold, there is a wind blowing, and that wind is blowing from this direction. So this is the velocity of the wind. Now this is the velocity of the plane relative to the wind. So without any wind it would go like that. This is the velocity of wind, and now we want to see what is the combination of those. So what is the real velocity of the plane? So this is the velocity of the plane relative to the wind. The wind's blowing this way, so we know when we add vectors we go tip to tail. So here's my velocity of the wind, and there's my resultant, which is my velocity of the plane. So we can say that the velocity of the plane is equal to the velocity of the plane relative to the wind plus the velocity of the wind. Or if we want to get this by itself, the velocity of the plane relative to the wind is equal to the velocity of the plane, that'll stay on that side, this one will have to come over, minus the velocity of the wind. Now that allows us to actually work out relative velocities. As a more general rule, we can say the velocity of A relative to B is equal to, now you can see from this is that whatever letter goes first there goes first over here, so it'll be the velocity of A minus velocity of B. Now if velocities are vectors, we should be putting a little squiggle underneath all of those to show that they are velocities. So that'll do scenarios, and we're going to look at a few in a minute, but that'll do scenarios of, say you've got an intersection, so we've no longer got this scenario here. So we've got A travelling here, and we've got B travelling there, and we can work out what's the velocity of B relative to A. So if you're in A, what's the velocity of that relative to the velocity of A? So the velocity of B relative to A would be equal to the velocity of B minus velocity of A, and so you can work that out. All right, so we're not going to do that one now, but we'll do one with a ship or a boat, if you like. So we'll get our boat. we'll move our boat down here. Okay, and we've got the boat relative, so we've got a current going on, and we're both trying to cross, so we've got so the velocity of the current is equal to 5 knots, and the velocity, so without the current going on, the velocity of the boat relative to the current, let's just say it's travelling at 10 knots. And as you can imagine, if the boat is not relative to the shore but relative to the current, it will go straight across. You've got the velocity of the current going down there. So this is going to be the velocity of the boat, so that's going to be equal to 5. So the velocity, this will be my velocity of the boat. So the velocity of the boat relative to the current plus the velocity of the current is equal to velocity of the boat, just by using a triangulation and adding tip to tail. We can find the magnitude. Well, what we can do now is put them in I and J components. So we've got the velocity of the boat relative to the current. Now that's just going straight across, so that'll be 10I. So we're trying to find this. And the velocity of the current will be negative 5J. Will be the velocity of the boat, and so that's 10I minus 5J. Now, that's in component form. To actually find out the magnitude and direction, so we've got the absolute value of the velocity of the boat will be equal to the square root of 10 squared plus negative 5 squared is equal to the square root of 125. And the angle, so this would be my theta, so tan of theta is equal to 5 over 10. So theta equals an angle whose tan is of a half. And that's calculated using a calculator. That can be calculated using a calculator. So the velocity of the boat is root 125 knots. At angle whose tan is a half, you could work that out in degrees, and that'll be south of east.